Before we start modeling the building, let's take a minute to understand how lava handles the lateral load path. Whether you're designing for wind or seismic, the loads will follow the same basic path through the building. First, the diaphragm collects the lateral force acting on the roof or floor. Those forces are then transferred into the shear lines, which act as collectors and distribute the load to the appropriate shear walls. Finally, the shear walls resist those loads and transfer them through the structure to the foundation. Lava designs those shear walls and hold downs to resist this load. As we build our model, we will follow a similar sequence. One important concept to understand is that lava models the x and y directions independently. Each diaphragm, shear wall, and shear line belong to either the x direction or the y direction. In this diagram, we can see how x direction is shown with the diaphragm, which collects that load, takes it to the shear line distributes that load to the shear wall below. The same thing would be done in the y direction. Before we draw the diaphragms, I always like to take a quick look at where the shear walls will be. Even though we're going to draw the diaphragms first, it's much easier to think through the picture of where those shear walls are going to be. So we're looking at this plan, we can see that we're going to have shear walls along the exterior and one interior wall at the front of that bedroom suite.
We'll start at the roof level. We'll switch the diaphragm to the X direction and notice that the lava display will drive the diaphragm in that selected direction. This makes it easier to work without extra geometry cluttering the screen. First, we grab one edge of the model and drag the mouse all the way to the other edge of that diaphragm region. So we'll draw in these two diaphragm regions from left to right to create those diaphragms in the X direction. Now shifting over to the Y direction, we create one large diaphragm region across the entire model, as we only have shear walls on those outer edges in that direction.
Next, we'll start drawing the shear walls. Modeling shear walls are just like drawing beams. You can just click on one point and then draw it, drag your mouse and click on the end point. You can also double click on the shear wall itself to set the exact length. Jump over to the Windows tab, and you can create your own window by just dragging your mouse inside of the window. And then also you can fine-tune the size of that window location and height. We are also seeing here that we're using force transfer and openings as a way for the analysis to run, but we can also choose between perforated. After you've made your changes, you can then say Apply Changes and OK to exit this dialog. We can also copy and paste different elements. So now that we have this shear wall created with its openings, we can copy and paste it here, and we can create other shear walls from scratch as well. The only change we'll make is flipping the sheathing side for a cleaner graphical display. This doesn't affect the analysis results, just the graphics. We'll continue to draw all of the walls and now in the Y direction as well. The last step on this level is adding the shear lines. Think of the shear lines as the connection between the diaphragms and the shear walls. They collect the diaphragm forces and distribute them to every shear wall that falls within that shear line. As you draw the shear line, make sure it includes both the diaphragm edge and all of the walls that should resist those loads. We'll repeat the same workflow on floor plan 1. Let's switch over to floor plan 1. This floor requires one diaphragm in the Y direction as we draw it across the entire model, because we'll have shear walls on the exterior walls. And in the X direction, we'll be drawing in 3 diaphragm regions, because we'll have 2 interior walls dividing those areas between those diaphragm regions. We can copy walls from above down to the lower levels. Since some of the walls are stacking, it's easy to make this copy. We can also redraw ones that are not stacking. In lava, walls don't have to stack. The loads will be carried directly from above into the diaphragm if they're not stacked, so we can have discontinuous shear walls. Some locations don't have enough wall length for a conventional plywood shear wall. In those cases, we can switch to the wall type of a pre-manufactured panel such as Simpson Strong Wall. Once it's configured, we can simply copy this to the other locations in the same conditions. Finally, we'll add floor 1 shear lines just as we did on the roof. Before moving on, make sure each diaphragm is connected to a shear line and each shear wall is assigned to a shear line. Once that's complete, the lateral system is ready for us to move on. In the next tutorial, we'll move on to running the analysis and reviewing the results for the design. Thanks for watching the video, and check out more on lavabuild.com.